Okay, so there's a lot on the screen right now, and I'm trying to preload some of this, so take a look over here. This is the problem we're solving that I'm outlining in blue. It is a rational equation, and it's a kind of ugly little beast, because if you follow the traditional method, which I've given you a sample of right here, you can see this is going to take a little while. Just briefly outlining the steps. First, you would find common denominators, okay? Having gotten the common denominators, then you would clear the denominators through multiplication. Then you would combine like terms, find yourself at a quadratic, and because this thing right here is gross, I don't want to spend my time trying to factor that. I'm just going to use the quadratic formula. Okay, and when you pull out your negative b plus or minus b squared, etc., eventually you get down to a solution. So if you would like to go through those steps, right, I'm just going to zoom out a little bit here. Go ahead and freeze the screen there, pause your recording, and try to follow this yourself. But I would like to do a different technique. That's the traditional method. We're going to solve this now instead using quadratic form, in other words, U-substitutions. We've focused on this from time to time. U-substitutions are a useful technique if you want to avoid some work, and every now and then you're given an equation that is of the proper form, namely the quadratic form, and you can use U-substitutions to solve it a lot easier. So what I'm going to do here first is set u equal to the middle term. It's almost always the middle term. In this case, that would be x plus 3 and x minus 6. You can see that right in the middle of our equation here. And if that's what u is, then u squared is just going to be x plus 3 over x minus 6 squared. And you can see that's essentially most of the equation that I'm dealing with. If I make those substitutions, look what we get now. U squared plus 2u equals 8, okay? Which easily rearranges into this. U squared plus 2u minus 8 equals 0, which if we factor becomes u plus 4, u minus 2 equals 0. And now we have two equations. U equals 4 and u equals negative 4 and u equals 2. So now what I'm going to do at this point is plug back in those u values. Okay, remember u is equal to x plus 3 divided by x minus 6, and that's equal to negative 4. And u is also over here equal to the same thing, x plus 3 over x minus 6 equals 2. Well, these equations are comparatively simple. There's a lot less going on here than the mess that I had at the very, very beginning, the traditional method. I'm just going to multiply by the denominator over here, and I get negative 4 times x minus 6, which I'll just go ahead and simplify the rest of the way down. Let's see what we get. Negative 4x plus 24. That becomes x plus, I'm going to bring my 4x over here and get 5x. I subtract 3 from each side and I get 21, which means x equals 21 over 5. Okay, that's one of my solutions. Next solution, I multiply by the denominator. X plus 3 equals 2 times x minus 6. Then I get x plus 3 equals 2x minus 12. Okay. I subtract an x over to the side, add 15, and now I'm at this stage. So there's my two solutions. Double check real quick just to prove ourselves on the level here. These are the exact same solutions we got by the traditional approach, but a lot less work. So the reason you're doing a lot less work is because we're breaking this into simpler equations. This U substitution right here, right? If you can break them into the simpler intermediate equations right here, it really unloads a lot of the work that you have into some basic factoring techniques instead of going through big stuff like on that side. A review of why this works. Remember, here's what's required. You have to have what's called quadratic form. Okay? If you don't have quadratic form, this neat little trick here would never work. It has to be something squared plus a linear version of that something equals a number. Okay, that's essentially what we're